pretty much. Okay. All right, so we're on to topic 2. We're looking at quadratics and rational functions and a few other transformations, things like that. Once again, this is not exhaustive. I'm just going to do 5 questions. All right, so first of all, rational functions. Rational functions. What is a rational function? It's a function that's set up as a fraction. That's what rational means, fractions. They have some key features. And the main one is the fact that they have asymptotes, that they have a line that they tend towards but don't necessarily cross. Okay, so let's look at this one. I'll rewrite it so you can see it a bit better. This is this function, ax plus b, 2x plus c. Okay, give some extra information. A, b, c are integers. X cannot be this number. We'll look at that in a second. Given that this has asymptotes at -5 and 2, x equals -5. So if I did a little sketch, x equals -5, there's an asymptote here. That's x equals -5. And y equal to 2, there's an asymptote here. So something like that would be where the asymptotes lie. And at the point 1 minus 1/12 is on the graph. So 1 and minus 1/12, so here, or so, is on the graph. So I'm just doing a little sketch maybe to help us, is on the, here, that's 1/12, that's this point. Okay. All right, so that point, I have a good idea what shape it's going to be. It's going to be one of these, I think. No, you can't see that. One of these. So it's going to look something like that.
How do you know?
Because there only is 2 options with this type. It's only going to be like that or like this. How do I know which one? Because this point is in this quadrant. So as soon as you know that, it's going to be there and there, these 2 quadrants of it. All right, well, let's have a look. So the vertical asymptote, that's going to be the x equals 1, isn't it? It's vertical. It's got to do with the denominator here. That cannot be 0. If it is 0, it's an asymptote. So you let the denominator equal 0. So 2x plus c must equal 0 to Okay, so we already know what x is, so we could find out what c is. C will not be 7 though. So 2 times -5 plus c is equal to 7, because we already know what x is. We already know what the asymptote is, that x value. So -10 plus c is equal to 0, so c is equal to 10. Because we knew the asymptote is -5. Okay, so we found what c is. So I can rewrite my function as fx is equal to ax plus b all over 2x plus 10. So we just need to find a and b. We'll look at the horizontal asymptote now of this type of function. You are looking at, there'll be number here plus a number all over number here plus a number or minus a number. These 2 give me the horizontal asymptote. One over the other will give the horizontal asymptote. So we have a over 2 in this case, a over 2. The horizontal asymptote in this case is a over 2. Okay, but we know what it is from the graph. It is 2. So a over 2 has got to equal 2. So what is a? A must be 4, yes. A must be 4. So we know a is 4, we know c is 10, so we're nearly done with the function now. We have our function now reads 4x plus b all over 2x plus 10. The only thing we're left to find is b. The only bit of information we haven't used is what? The point. So we have a point 1 and minus 1/12. This point satisfies this, so it is on this function somewhere. I know when x is 1, the y value is 1/12. So when x is 1, it equals 1/12. So remember, fx is the same as y. This will be fx or y, and this is x. So 1/12 equals 4 times 1 plus b over 2 times 1 plus 10. And nicely enough here, 2 plus 10 on the bottom gives 12 as the denominator as well. And I get 4 plus b. So what must b equal? 4 plus what equals minus 1? Minus 5, yeah. B must be minus 4, take away 5 and be minus 1. Yeah. It says, given that the graph of f of x has these asymptotes, hard to read, I know, but and this point. So that's all the information. Okay? All right, let's move on to a... Okay. We're going to move on to a quadratics question next. So quadratics in general, we know, have two major shapes, only two shapes, this one and this one. This one is when it's positive x squared, this one is minus x squared. This very turning point here, the max or minimum, is sometimes called a vertex, isn't it? This is the max one, and this would be a min one. This is the maximum point of this graph, and this is the minimum. Isa? Yeah. Point of inflection, yes, that's calculus, yeah. Second, you should, most people need to go straight to second derivative there. But we'll look at that when we do topic 5. Conversions? Between what and what? Units? Yeah. Oh, converge. Yeah, we did that yesterday. Were you here? Oh, convergence of a sequence is that sequence that instead of getting bigger, it gets smaller. This is a classic example. If you add up this sequence, it converges towards a number. You see that? It converges. So I'll redo that. 16 plus 8 plus 4 plus 2 plus 1 plus a half. These numbers are going to get smaller and smaller and smaller. So much so, in fact, it actually converges towards only one answer. No, it won't. 16 plus 8 is 24 plus 4, 28 plus 2 is 30 plus 1, 31 plus a half, 31 and a half plus a quarter, 31.75 plus an 8. It goes towards 32. It converges towards 32. That's what that means. Okay. That's from topic 1. Yeah. All right, let's look at question 2, which is a quadratics question. It's going to be even smaller for you guys to read. I'll zoom in on the screen. That's way better. Oh, I should have printed this bigger. I'm sorry. Okay, I'm gonna describe this question to you mostly. Maybe if you're watching this later, you'll see better if you zoom in. So it sets up, it says we have a function here as 2x squared plus p, or 4x plus p. So we're missing the constant term here at the end. The very first thing it says in part A is that f of x equal to 0 has 2 equal roots. Okay. Okay. And well, let's deal with that first. That's part A, and then part B is show p is equal to 2. So we'll do part A first. Show that p is equal to 2. Okay, so this first part has 2 equal roots, and it says, what is the value of the discriminant? What is the value of the discriminant? Okay. What does the discriminant tell us? So the discriminant is b squared minus 4ac. You can get 3 types of answers for that. You can get positive one, You can get it equal to 0, and you can get a negative 1. If the answer out of it is positive, there are 2 roots. Is 0, it has 2 equal roots, or the same root, or a repeated root. And if it's minus, it has no roots. So this one has 2 equal roots. So what is the value of the discriminant? In A part 1, the discriminant equals 0. That's the value. It will equal 0 when we do it. So that means when we do it in part 2, find the value of P, we know that B squared minus 4AC equals 0 from this. So B is 4, so 4 squared minus 4 times A is 2. Remember, A is we're talking about the coefficients here. 2, and P is C. This is C. Equals 0, so we can solve this for P, and I think P ends up being 2. And that's what we needed to show. So we had to show it, we couldn't use it. Okay, so that's part A. For part B, I'll write it again. It's looking for the equation of the axis of symmetry. Oh, I spelled it wrong. It's looking for the equation, and it's looking for the coordinate of the vertex. So we had a diagram on the other page. So I'll just get rid of that for a second. If we have a U-shaped graph, how do I know this is a U-shaped graph? It's a quadratic, but how do I know it's not an N-shaped? Coefficient of what?
X squared.
X squared is positive, yes. It's a positive number, so it's a U-shaped graph. So I know the vertex is going to be here at the lowest point, and the axis of symmetry goes through the vertex. Yeah, it goes like this. Yeah. Goes through the vertex. Okay, so this line will have a title x equals something. Always. So we're just looking for the x coordinate. All right, how do we find that? All right, if we can't remember, it's in our formula booklet. Here it is here. Axis of symmetry, x is equal to minus b over 2a. X is equal to minus b over 2a. Okay. This would be non-calculated. Okay, so part 1, the equation, p I know to be 2. So I'm looking for x is equal to minus b over 2a. So b is, from before, is 4. So it'd be minus 4 over 2 times 2, which gives x to be minus 1. X to be minus 1. So that's the axis of symmetry. The coordinates of the vertex then. So what we found is we know that x is minus 1 here. What's this point then? It will contain minus 1. And we're looking to find the y part of it. How do we find the y?
Y equals to X plus
No, that's equation of a line. No. We have the function 2x squared plus 4x plus 2. We have this function. So we just sub in x into this, and it'll give you out the y value. So the function at minus 1 will give out the y value, give out the other part of the point. So I just need to sub in minus 1 into this. And this will find me the second part of it. I think it's 0. So my answer to part 2, the coordinates of the vertex are minus 1, 0. So I know that's the lowest point of the graph. Minus 1, 0. Okay. I'm going to write the next part of the question because you can't see it anymore. So we still have this function, fx is equal to 2x squared plus 4x plus 2. This is a quadratic. We found that out. We found the lowest point. Write down the solution. part C, write the solution. What is the solution to a quadratic? Where it equals 0? Okay, yeah. Graphically, can you describe that? The x-intercepts, yeah. So normally on a quadratic, it goes through it twice here. It'll have 2 x-intercepts. What do we know about this quadratic? It only has 1 because the discriminant was equal to 0 at the start. It only has 1 place, so it'll just touch off and go like this. We already found a second ago this point. Where is that point? Minus 1, 0. If I were to draw it, it's here, yes. But it's on the x-axis. That's minus 1, 0. That's on the x-axis. So the solution is x equals minus 1. That's where it crosses, it touches the x-axis. It doesn't actually cross. So that is the solution. Part D then asks to write the function in this form. And we came across this, I think, in the mock exam, didn't we? This is vertex form. Vertex form. How do we go about changing? So my original function is here to this. Hmm? Well, we're not sure. It probably will be 2, considering 2 is there, yes. I don't think we need to do that much. What we know the vertex. We know this point is minus 1, 0. We know that. I think you could just say x minus 1 here. Remember, this is h and k, and this is the vertex. hk, this is the vertex. And minus 0 is just going to be gone. Yeah? And as Gabe says, you're seeing that there's a 2 here, so we need a 2 here. You can complete the square for this, which is a bit more complicated. Not necessary, but you can just do it. Now, are we sure that this equals that? Well, if you're not sure, you can just always just multiply it out really quickly. This one's going to be x squared. There's going to be a 2x in the middle. I'm going to be left with plus 1. If I multiply all those by 2, I do get this. So yeah, that's okay. That's it done. K is 0. We already knew the vertex was h and k anyway. So this is called vertex form. There is another form that you might need to know. I call it intercept form. This form. It's not required in this question, but it is the other one of these that has like the A multiplier. This is the intercept form, and these P and Q are the roots or solutions. Or zeros. Remember, roots, solutions, zeros kind of all mean the same thing. It is where it crosses the x-axis. So if we know where it crosses the x-axis, and you kind of know this already because this is the way you solve them. All right. Okay, and part E then is a reflection, not a reflection question, it's a transformation question, which we'll do another one in a second. It says the graph of the function g, I'll just show you the question, I probably can't see it, but the graph of the function g is obtained by the graph of f by reflection in the x-axis. Find the coordinates of the vertex of g. So here's f. This is this is our sketch of ff. If this is reflected in the x-axis, what will it look like?
Minus 1, 0.
It'll just be here, won't it? What is its vertex? Also minus 1, 0. So minus 1, 0 is that last answer. Okay. I think the next, it's not much bigger, but it's more space for me to write at least. Okay, the next question is about your inverses and composites and that which you were not wonderful at either in the mock exam. Let's have a little look at this one. I'm going to write the function for you. Once again, it's tiny. This is our function. In part A, it asks for f with 1 and f with 2 put into it. So that should be pretty straightforward. We know how to sub in f with 1 max, don't we, and f with 2. So f with 1 put in it would be 2, 1 minus 1, which is 2 to the power of 0, which is 1. And f with 2 put in it is 2 with 2 minus 1, which is 2 to the power of 1, which is 2. Fantastic. That wasn't too bad. The next thing I'm going to ask you, it's not in this question, that we need to know that this symbol is coming up in part C, but we need to know that symbol. Inverse. At least 3 of you thought this symbol meant first derivative. It is not. It is inverse. Okay, we'll get to that in a second. Part B asks, graph the function, this one, graph this, and its inverse on the same axes without a calculator. Okay, it would be a sketch. How can I graph it? Well, we have a couple of points already, don't we? This means 1, 1 is on the graph, doesn't it? And this one means 2, 2 is on the graph. No. So let's use our scale. Looks pretty small from what 1, 1 is on and 2, 2 is on. It's not a straight line because we might need another point just to show. Well, get a third point, yeah. What about f0? What's f0? Is it 2 to the power of 0 minus 1, which is 2 to the power of minus 1. What's that? That's a half. Yeah, so 0, a half is another point, so it's not quite, it's going to tail off. It's going to be like, is it ever going to cross this line? The x-axis? Max, what do you think? As in, is 2 to the power of x minus 1 ever going to be a minus number? Which would be on this side. No, it never can be a minus number. Why not? Because even when we get a minus number in the power, it just makes it a fraction. So it's getting closer and closer to 0. Yeah, it's going to like come along here. So it's going to be, I probably haven't drawn this big enough, but it's going to be something like that. That'll be it. It's going to get exponentially bigger because this is an exponential graph. What will its inverse look like? Yes. Graphically, what line do I have to reflect it in? The y equal x one, yeah, this one. So you would get a ruler out. You'd draw this line. Of course, this line should go through that point, but I need to do that again. Should go through both these points if I did it correctly to scale. And then it's going to be something like that. Well, I haven't got the number of the function, the actual inverse function yet. Well, we have just a graphic representation of what it should look like. Because I've just reflected it in this line. I've tried to do equidistance. I kind of knew it would go through 1, 1 and 2, 2 because the x and y's will have swapped. I also know it should go through a half here because the x and y's will have swapped. Does that make sense? You're swapping the x's and y's. That's what reflection in that line does. Part C actually asks you to find f inverse. Okay, so our function is a little bit tricky here. It's this one, y is equal to 2, x minus 1. I've switched to y instead of fx because I'm going to have to swap x's and y's. So let's swap the x's and y's. this is our process of going through an inverse. Swap the x and y's, and then do what? Well, I know you might have to use logs, but you want to get y equals again. But the y is in a tricky spot here. How do I get the y out of the exponent? I use logs, which is from number and algebra, not from this unit, but we'll do it anyway. How do I rewrite this as a log? So my base is going to be 2. X, y minus 1. Yeah. The power now becomes the answer. And this is our base, and the former answer becomes in here. Well, we want y equals, so we got to have this 1 on the other side. So we add 1 to both sides. Plus 1 is equal to y. And then do not leave your answer y equals. Rewrite it. F inverse x is equal to log 2x plus 1. Make sure to write that. Yeah, you might lose a mark, yeah. I know it is annoying, but that's life. Okay. The next question asks us, so we have, I'm going to move on to another page. We have our function, which was 2 to the power of x minus 1. We have its inverse, which is log 2x plus 1. And then it asks in the next question for the domain and the range of each. All right, so I'll just switch to this paper now. I want the domain and the range of each. So let's talk about the domain of the original, fx. What is the domain of fx? What x values can I sub into this? Anything. I can literally put it in any, there's no reason I can't put it in. The only thing you're looking for is dividing by 0, and that's not happening here. X can be 0, that's fine. That's just giving us a number again. So how do I write that? X can be anything. X an element of 4, yeah. That's the all real numbers, yeah. You can write that like this. This is the fancy way of saying X can be a set of all real numbers. Or X, you'll get it just for this. You get the marks just for that. The range then of this. Okay, so luckily we had the graph of the function. The range is the output, the y values. So x values for domain and y values for range. So we look at the y values of this, the original function. And I think James said that this is never going to go below this line. It's going to get closer and closer to it, but it's never going to go below it. It's going to be fractions all the way. So as Stefan said, that's going to mean it's above 0. Not going to equal 0, it's above 0. How do we write that? Y values for range. Y is above 0, so y is greater than 0. I can use set brackets again if I want to change that, but this is the important part. Y is above 0. Okay. What is the domain of the inverse? So the inverse was log something, something, something. It's here. It's log x 2x plus 1. What do we know about the domain of the original and the range of the inverse? They are the same. A key point in domain and range of functions and its inverse is if you don't like using the domain of the original, you can use the range of the inverse. The outputs become the inputs, and x's and y's are all swapped. X's and y's are swapped, so I don't even need to look at my graph. I will in a second, but I know x is greater than 0 because it's the range. It will be the same as the domain of the inverse. And I can look at that now in the graph I have drawn earlier. I can see that this is doing the same thing. It's just going towards this axis. isn't it? It's going towards here. It's not going to cross it. So it's never going to be a negative x. These are all the negative x's on this side. It's never going to be negative x. And the same thing then for the range of the inverse is what? All real numbers. Yeah. Why? Why all real numbers? Okay. All right, let's do maybe two more, maybe just one more. Okay, another one that you're not going to be able to see. I'm definitely going to print these bigger next time. Okay, so we have an exponential function here. N is equal to 120 multiplied by 1.04 to the power of t. And the first question asks, find the number of people who started the settlement. So this is the number of people in a small island t years after a settlement starts. So how many people started the settlement? You could probably read this off the thing. How many people started the settlement? So this is a t years after the settlement starts. The settlement numbers increase. So it looks like it's getting 120. 120. You could say initial. Anything that's the initial period starting time is 0. So you can do that if you want. 120, 1.04 to the power of 0. Anything to the power of 0 is 1. So we just have 120. Or you could have just read it off. Part B, find the number of people on the island after 4 years. So t will be 4. We once again, this is a calculator question, by the way. 1.04 to the power of 4. We type this into our calculator and we get around 140 to 3 significant figures. No problem with that. And this is the tricky part. How many years will it take the number of people to double? Okay, so what will I write?
240 is equals to
240. Yeah, 240 is double the 120 that starts, and I have to solve this for t. How do I solve it for t? N solve or divide both sides by 120. If I divide both sides by 120, I think I end up with 2, which makes sense, doubling 1.04 to the power of t. And then use our old friend logs. Log base 1.042 is equal to t, and you will get t equal to 17.7. You could definitely graph it, yeah. And where this line crosses this line, curve will cross that line. That'll be okay. So about 17.7 years for it to double. I'm going to do one more question on transformations, and then if I can find it, and then we look at the homework. Oh, once again, too small. Okay, so we have this original function, which I'm going to redraw for you. It's got a weird shape. It's got like this shape here. That's the original function. We got a few bits of information. This is at 2. This is the point 1 minus 1, 1. Okay, so we have this. We're just looking at transformations. If I see this is my original function, and I see it's been transformed to this. You see that? What has happened? This is the original, and it's been transformed. This, what has happened? Move it 2 units on the x-axis. Which way? Is this to the right or to the left? remember when it's in with the x, it's the opposite. When it's in with the x, it's the opposite. So we would move this, and it would look something like this. That would be f with x plus 2. So this means 2 units left. Not right. Plus, opposite, in with the x. You need to know that. Okay, so that's part A. Part B says, right, fx has gone 2fx minus 3. What has happened?
No, it's going.
Expansion scale factor.
So, which way? So vertically is this way. That's vertically. This is horizontally. Which way has this one stretched? Yes, it's a vertical stretch. So if it's applied to the function on the outside, it's vertical. Inside, it'll be horizontal. If it's in here with the x, it'll be horizontal, which we might see in a minute. So this is a vertical stretch. Scale factor, what's the scale factor? 2. Okay. And what about minus 3?
Oh, it moves down.
Moves down. Down 3. Goes down 3. So this is not in with the x. Again, remember, if it's in with the x, it's the opposite. This is not. So this is a vertical stretch. Scale factor 2, and it moves down 3. So it's going to be slightly longer. Something like that. I haven't moved it down far enough at all. No, I have not. Moves down further than that, but okay. The next one, I'm not going to sketch it anymore because we're in a bit of a hurry. Y is equal to 4 minus fx. What has happened to this one? What is this translation? What has happened to it? So my original is fx. It has changed to 4 minus fx. What verbally, what has happened to this? Let's deal with this first. What's minus fx? Minus, if I multiply a function by a minus, multiply everything in the function by a minus, what happens? It's a reflection, yes. You use the. It's a reflection. Which axis? X, yeah. So this is all the y numbers. All the y numbers will now be minus when they used to be positive. The x numbers, the inputs will still be the same. You still put in an x number. The y numbers will be the opposite way around. So if your point is, if you subbed in 1 and you got 2 out, you'll now sub in 1 and get minus 2 out. So that'll be reflected in the x-axis. Yes? The 4? We haven't done that yet. What does the 4 do? Well, if it was written like this, what would you say the 4 did? Up 4. Same thing, it's just it's just up 4. Yeah.
That's confusing though.
It is a little bit confusing to put that in front, but that's translated. Okay, so note to remember, if the minus is applied outside the function, it reflects in the x-axis. If the minus is inside the function, it reflects in y-axis. And if we have something like this, I won't do any more of this question. If we have something like this, what effect does this have?
Scale factor 2. Y.
Stretch, which?
Vertical.
Horizontal stretch, it affects the x. The scale factor is the opposite to what you think. It's 1/2. Remember, if it's in with the x, just think the opposite. It's 1/2. That's it. Okay, let's run through your homework, and then I'll give it to you. I have it somewhere here. Yes. Let me give it, hand it out first, and then so you can look at it as we go, and you can take a note. And pass this. Okay, so there's 9 questions.
So you got a print larger.
I know, yeah.
The first one is
Yeah, it's tiny. Okay, I'm going to run through how to start them anyway, and then I'll go through all the answers then on Friday. All right, so sub in 3 is okay. This one, G after 3, G after f of 3 means sub 3 into the f function first, get that answer, then sub it into the g function. Inverse you should be able to do after doing the one we did today. Question 2 then, it's find the coordinates of the vertex. So you can use minus b over 2a for that if you want. X is equal, that will give you the x point of it. Remember, that's the axis of symmetry. And then you could find the y value by subbing it in. State where the vertex is a minimum or a maximum. Well, we know by the shape of the graph. If it's a U-shaped graph, it's a minimum. If it's an N-shaped graph, it's a maximum. The range of the function will be, minimum will be a U-shaped graph like this. Okay, I've drawn that pretty small. Minimum is like this. Maximum is like this. The range of a function, so once you have this point, in this type of one, the range, it's only going to go down. The range is the y values. It's going to be from this point down. Or if it's like this, it's from this point up. Remember, range is y values. Axis intercepts, you should be able to get that. If you can't use you may use the calculator if you're really stuck. But you should be able to, this is a non-calculator. Axis intercept, solve the equation. The first 2 are, yeah. I'll tell you if it's not. Question 3 then. Describe the shape. You should be able to do that. This is a calculator question. Use the discriminant to show. So you got to use the discriminant. Remember, that's b squared minus 4ac. To show it cuts twice, you need to get that number, and it needs to be more than 0. Find the x-intercepts. So it looks like you'll have to use the quadratic formula for that. X is equal to b squared plus or minus b squared plus or minus the square root of, minus b plus or minus b squared over 4ac, 2a. It's in your formula booklet. State the y-intercept. You can probably read that straight off the graph.
So what is this U?
Write it. 2 equal roots, that's going to be what? Discriminant. Very good. Use the discriminant in question 4. Question 5 is our rational function. Domain and range is here again, so there's going to be some breaks. If you're listening, it can be everything except for things. You'd have to write it something like this. That's everything except for this particular number. You can write it like that. Max and Bria, thank you. A sign diagram. Remember what that is. You need to put where it crosses the x-axis here, and then where it's positive or negative, where it's above or below the x-axis. An asymptote is put in as a dotted line. Maybe look it up online. I'm not going to be able to. I will go through it obviously on Friday. A sign diagram. Asymptote, dotted line, 0 is there. You should be able to get the rest of that one. Okay. Question 6 then is very similar to the one we did today. X-intercepts, vertex again. These are mostly quadratic questions. And then there's some transformations down here. So a horizontal, a vertical, and a compression of scale factor. Compression, so it got smaller instead of a stretch. Question 7 then is your exponential one. So it should be okay. Same as, very similar to what we just did, talking about the subbing in values for t. Question 8 then is another get the inverse, get domain and range of a function, so should be okay. Question 9 then is similar to what you had in the mock exam, and I put this in for a reason. You have a shape, You have to show that it equals the area. We'll do one of these after lunch. You have to show something is the area, and then it's a quadratic. So when you draw it, if this is the area and these are the dimensions, this will be the max area, this point. So the vertex you're looking for the max area. But we'll look at that after break, and we'll do it on Friday anyway. Okay, we'll see you guys at 1:45.